Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are, as we have already completed aldehydes, ketones, carboxylic chapter, today we are going to start a brand new chapter, that is your amines. Okay, so in today's class we will be covering about amines, their structure, classification, nomenclature and preparation. Okay, so I want all of you to sit with a notebook and a pen so that you can note down all the important reactions with my style, that is your flowchart diagram. Okay, and one more request, please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video, so please go there, join it so that you can get access to all these PDF notes, the question papers, solutions, everything in our WhatsApp channel. Okay, so please do not forget to join the WhatsApp channel and sit with the notebook and pen. And now let's get started to our first class of amines and without any further delay. Okay, so yes, now coming to the chapter amines, it will be covered in your 3 parts. Okay, generally I covered all the organic chemistry chapters in 4 parts, but this chapter will do it in 3 parts. Okay, so in the first part we'll be doing today's class, that is structure. One second. Yeah, in today's class we'll be doing structure, classification, nomenclature and preparation. In part 2, we'll be doing physical properties and chemical properties, that is in the next class. And in the last class, we'll be doing about diazonium salts, its preparation, physical properties and chemical reactions. Okay, so now coming to the weightage, so you can just expect, you can expect 2 to 3 questions from this chapter. Okay, so here's the numbers, 2 to 3 questions easily you can expect from these 2 chapters. Okay, this chapter. Now coming to the first topic, that is structure of ammonia. So first of all, you should know that ammonia structure, some basic important thing, that nitrogen hybridization here is sp3. Okay, if sp3 hybridization is there, that means there will be 4 sp3 hybrid orbitals. So these are your 4 sp3 hybrid orbitals, 1, 2, 3 and 4. In each of these sp3 hybrid orbital, out of this 4 sp3 hybrid orbital, 3 forms bond with hydrogen. Okay, and 1 sp3 orbital contains the lone pair. Right? There are 3 hybrid orbitals in which the bond is formed with hydrogen, and there is 1 hybrid orbital where there is lone pair of electrons. Now what is the structure of this one? This is your tetrahedral structure. Tetrahedral geometry. Now what happens generally in tetrahedral structure, the bond angle is 109 degree, right? Now due to this presence of this electron pair, what happens, there is repulsions. Okay, and due to repulsions, these bonds come closer to each other and the bond angle reduces to 107 degree. Okay, so the geometry is tetrahedral but the shape is pyramidal. Okay, so that is all about the structure of ammonia. Next, coming to classification. So if you see, ammonia has 3 hydrogens, right? N, you have 3 hydrogens. Now if 1 hydrogen is replaced with R group, then we call it primary. If 2 hydrogens are replaced with R group, then we call it secondary amines, and if all the 3 H is replaced with R group, then we call it tertiary amines. So you can see here NH3, 1 H is replaced, RNH2, this is primary. Now 2 hydrogens are replaced, only 1 hydrogen is left, that is secondary amines, and here you can see all the 3 R groups are removed, that is your replaced, that is your tertiary amines. Okay, that is about structure. Next, coming to nomenclature, this is very important. So under nomenclature, what happens, you should remember that the name ends with amine. Okay, so now if you see the first one, you have here CH3, CH2, NH2, right? So there are 2 carbons, so the name here is called as ethanamine, IUPAC name. Now what is the common name? Common name is ethylamine. Okay, next if you see this one, there are 3 carbons, so the IUPAC name is propane 1 amine, or you can say propanamine, and the common name is N-propylamine. Next if you see this one, this is your isopropyl group, so you can say it is propane 2 amine, that is IUPAC name, and the common name is isopropylamine. Next if you see this one, so this is a secondary amine, right? You can see out of this N, 2 R groups are removed, 2 H is replaced with R groups. So here what you have to do, here the name is taken like N-methyl, then N-methyl ethanamine, okay, N-methyl ethanamine. Now here, whether to take N-methyl or whether to take N-ethyl. So the smaller carbon group is taken as N-methyl and the longer carbon group is taken as the parent chain. Okay, and what is its common name? Common name is followed by alphabetical order: ethyl, methyl, amine. Okay, next if you see here, this one, this is a tertiary group, right? So here we have NNN trimethylamine, right? So you have NN dimethyl methanamine, and here you can say trimethylamine. Now if you see, this is again a tertiary. Here you have ethyl group, and here you have butyl group. So it will be NN diethyl butanamine, NN diethyl butanamine, and what is the common name? NN diethyl butylamine. Next, coming to this one, so this is your an alkyl group. So you have 1, 2, 3. So propene, so that is prop, 2 en, 1 amine, and the common name is very important, allyl group, right? So on the allyl position there is NH2 group, so allyl amine. Next, if you see, we have 2 amine groups, a 6 carbon chain. So you have here hexane 1,6-diamine, and here you have hexamethylene diamine. Okay. Next, coming to the aromatic amine, so this is very important. This is your aniline group, and the common name, IUPAC name, is either benzenamine or you can say aniline. Now here if you see, this is ortho position, there is CH3 group, so we call it orthotoluidine, okay, and or you can say 2-methyl aniline. Next, similarly here you have para-bromo aniline, or you can say 4-bromo benzenamine or 4-bromo aniline. Now here if you see, this is structure is like this. You have a secondary group here, CH3, right? So the common name you can say NN dimethyl aniline, and here you can say NN dimethyl benzenamine. Okay. Fine. So here a small exercise for you. So you have to identify them as primary, secondary and tertiary. Okay. So let us quickly start this one. So first one, if you see N, there are 3 H, already 2 H is there, that means only 1 H is replaced. So this is primary. Now if you see here, there is no H at all with nitrogen, that means all the 3 are replaced. So this is tertiary. Now if you see here, again with this H, with this N, we have 2 hydrogens, right? So only 1 hydrogen is replaced. So this is primary. Here also if you see, only 1 hydrogen is there, that means 2 hydrogens are replaced. So this is secondary. Okay, fine. Next we'll go to the fourth topic, that is preparation of amines. Okay, there are 6 methods of preparation total. Okay, so we'll see them. The first one is reduction of nitro compounds. Okay, first one is reduction of nitro compounds. Next, ammonolysis of alkyl halides. Next we have reduction of nitriles. Next you have reduction of amides. Okay, and fifth one Gabriel phthalimide, and the sixth one is Hoffmann bromamide degradation. Okay, so how to remember this 6 method? 2 are name reactions, we can easily remember, Gabriel phthalimide and Hoffmann bromamide degradation. Okay, next 3 you have only reduction of nitro compounds, reduction of nitriles, reduction of amides. Okay, 3 are reductions reactions, reductions of nitro compounds, reduction of nitriles and reduction of amides. And one more is there, ammonolysis of alkyl halides. The second one is ammonolysis of alkyl halides. Okay, so now let us revise once again. First is reduction of nitro compounds, ammonolysis of alkyl halides, 2 more reduction is there, reduction of nitriles and reduction of amides, then 2 name reactions, Gabriel phthalimide and Hoffmann bromamide degradation reaction. Okay, so now let us see the methods of preparation. So the first one I told you was reduction of nitro compounds. Okay, so the first one is this one, the first method, that is reduction of nitro compounds. Okay, so this is your nitro group. Here you have to remember the reagents. So you can use either H2 palladium ethanol, or you can use SnHCl, or you can use FeHCl. Hydrogen palladium or SnHCl or FeHCl. Okay, so that NO2 group gets converted to RNH2. Clear? First one. Second method is what? Second method is ammonolysis of alkyl halides. Okay, so now if you see, X is delta minus, R is delta plus. NH3 is a nucleophile. This one can attack here, right? So what happens? We get a salt. So RNH3 plus and X minus is formed. After that, if you treat it with water, okay, then what we will get? OH is here and one H is taken out, we'll get water. Then Na takes this X, from here one hydrogen is removed, two hydrogens are there to give you RNH2. So, okay, so this one is your primary amine. Now from primary amine you can treat again Rx. So again what will happen? One of the H will be replaced to give you secondary amines. Again if you treat it with Rx, another H will be replaced to give you tertiary amines. Again if you do one more, then you will get quaternary Rx. Okay, so the ammonolysis of this one haloalkanes, the problem is that we get a mixture of products. Okay, you cannot get only primary amine, it is very difficult. You will get secondary, tertiary as well as quaternary amines with this, right? So that is why this method is not a very good preferred method, because of the preparation of, you have a series of products. Okay, next third one was reduction of nitriles, right? So third one is reduction of nitriles, that is RCN reduction. Again you should remember the reagents here. You can use H2 nickel, okay, or you can use LiAlH4, or you can use Na sodium amalgam C2H5OH. Okay, so reduction of nitro compounds also we had three reactions, three reagents. First one was SnHCl, or you can use FeHCl, or you can use hydrogen palladium. Reduction of RCN, again you have three reagents, you have to remember H2 nickel, lithium aluminium hydride, or sodium amalgam in presence of C2H5OH. Okay, so here you can remember hydrogen nickel, hydrogen palladium is common to both. Next we have fourth one, that is reduction of amides. Reduction of amides. Okay. So for RCH2NH2, if you just treat it with LiAlH4, so we will get RCH2NH2. Okay, this one will get converted to RCH2NH2. Okay. Next, the sixth one we'll discuss, that is Hoffmann bromamide degradation. This is very, very important reaction. Hoffmann bromamide degradation. So here there is an amine, the reagent used is Br2 in presence of NaOH. So what happens? This group RCO, this group is vanished and we get RNH2 directly. Okay, so this is what you should remember, that if you want to prepare an amine of less number of carbons than the amide group, okay, same number of carbons then LiLH4, less number of carbon than Br2 in presence of NaOH, Hoffmann bromamide degradation. Okay, so this is the sixth method. Now you will be asking where is Gabriel phthalimide method, so that we will see here. Okay, so this is the fifth method, that is Gabriel phthalimide reaction. Okay, so first we take a phthalimide group, okay, then you treat it with KOH. So what happens? This H and this OH forms water and we get a potassium salt of this one. Okay, next what happens? Now you treat Rx. So now if you see, this is minus, this is plus. So what will happen? Plus will come here, minus will go there. So we will get NR. So this is called N-alkyl phthalimide. Now if you treat it with NaOH, so these bond cleaves. Okay, here we get OH, OH, and we get RNH2. This forms your RNH2 and this takes your ONA, ONA minus. Okay. So that is how we will get RNH2. So here you should remember that this method is used only for, can be used only for the preparation of, primary amines. Okay, only for the preparation of primary amines this method can be used. Okay, now we will go and revise them. Okay, let me clear this all ink here. Okay. So for reduction of nitrogen compounds, we had three reactions, three reagents, right? So what are them? H2 palladium, then you have SnHCl, or you have FeHCl. Okay. From ammonolysis of alkyl halides, you just treat Rx with NH3. Okay. Next, reduction of nitriles, RCN. So here also we have three reagents, H2 nickel, Okay, then you have LiAlH4, or you have sodium amalgam in presence of C2H5OH. Next, reduction of amides, that is your RCONH2. So for this we need lithium aluminium hydride. For Gabriel phthalimide you need for Gabriel phthalimide you need phthalimide, right? You need phthalimide and RX. Okay, and you should remember that it will give you only primary amines. For Hoffmann degradation you need Br2 in presence of NaOH. Okay, here you will remember one carbon less product is formed, right? So that's all. Now it's time to practice. Okay, so first let us do this question. Let's select the IUPAC name of the following. So you can see this is a tertiary group, right? So we can have NN dimethyl. So NN dimethyl. So this is wrong, this is wrong, this is wrong. NN dimethyl propanamine. So correct answer for this question will be option number D. Okay. Next, you have CH3CN with H2 nickel. So just now we have seen with CN group we can reduce it to amines. So I'll get CH3 CH2 NH2. So that is my ethanamine. So correct answer is option number B here. Next, the product of the chemical reaction. So bromine with NaOH. What is the name of this reaction? Hoffmann bromamide reaction, degradation reaction. Hoffmann bromamide degradation reaction. So if you remember what happens here, this CO group will vanish, right? So I'll get CH3NH2. Correct answer is option number D here. Next, Gabriel phthalimide synthesis is used for the preparation of, so just now I told you it is only for the use of or the preparation of primary amines. Next, one of the following amides will not undergo Hoffmann bromamide reaction. What is it? So you have to remember that Hoffmann bromamide reaction is also possible only with primary amides. Okay, so that means you need to have this group RCON, 2H group has to be there. Okay, now if you see NHCH3, it will not be there. Here you have CH3 CH2 CONH2, here you have CH3 CONH2, here also you have CH3 CONH2. So this is a secondary amide, so this one will not undergo. So correct answer is option number A. Next, a secondary amine is, so this is your previous year question. Okay, a secondary amine means what? In ammonia there are 3 hydrogens, right? 2 hydrogens will be replaced with R, there will be only 1 hydrogen left, and that is called as secondary amines. So compound with an NH2 group on the carbon atom with number 2 position? No. A compound in which 2 of the hydrogen of NH3 have been replaced with an organic group, right? That is the correct answer, option number B. Next, okay, here one question is there. So this you can see a monolysis is happening. So what I'll get? C6H5CH2Cl. So first reaction, what will happen? See, C6H5CH2Cl, and we have here NH3. So this will attack on this one, right? So what I'll get? C6H5CH2NH2. After that you have 2 times CH3. That means all 2 hydrogens will be replaced. So I'll get C6H5CH2NCH3 and CH3. Let us draw this figure like this. We'll get C6H5CH2. Then you have NCH3CH3. Right? So now if you see, this is NN dimethyl, right? NN dimethyl. This should be methyl, but in this methyl this is a benzene group attached, right? Or you can say phenyl. NN dimethyl phenyl methanamine, right? So correct answer for this question is option number A. Okay, again this is also a previous year question. Next, the correct sequence of reactions to be performed to convert benzene to bromoaniline, M-bromoaniline. So you have to convert benzene to M-bromoaniline. Okay, so you have NH2 here, M-bromoaniline. Okay, so first of all, let us see all the options. If we do nitration, so what I'll get? First I'll do option number A, let me check. So if I do first nitration, then what I'll get? I'll get NO2, right? Then you do reduction. So if I do reduction, we'll get NH2. Okay, and then we have to do bromination. So here what is the thing that you should remember, that NH2 is a electron donating group. So what is then means? That means it is ortho para directing. So if I do bromination now, so I will not get meta position. You will get either ortho or you can get para product, NH2Br, right? So that means this cannot be the answer. Next one, if you see, first you do bromination. Okay, so first if I do bromination, I'll get Br. Then you do nitration. If you remember, nitration, bromine group is also a ortho para directing group. So what will happen? Nitro group will come here. Ortho para directing, so nitro group will come here or here. So that means this also cannot be the answer. Next, let us see first option number C. So this is option number B. First we are doing nitration, NO2. Okay, then you are doing bromination. Yes. Now if you see, NO2 is a meta direct electron withdrawing group, so it is a meta directing group, so it will convert to bromine here. Now if you do reduction, NO2 will get convert to NH2, right? So this will give you meta bromoaniline. So correct answer for this question is option number C. Okay, next, again you have to find the reaction. 2-bromopropane is there. You have 2-bromopropane. Then you have alcoholic AgCN. So if you remember, KCN converts Br to Cn, but AgCN converts it to NC. So what I'll get here? CCCNC. Then you have 2 LiLH4, that is reducing this one. So you will get like this, NCH3 and NH. Right? So now here you can see this is a secondary amine group. Secondary amine group. So you have here N-methyl and then you have isopropyl group. So you can see N-methyl propane 2-amine, right? And so isopropyl is a common name, not a UPSC name, right? N-methyl propane, here the position is not mentioned and butanamine is wrong. So you have N-methyl propane 2-amine. So correct answer is option number B here. Now next one, which of the following names of amines belongs strictly to the common system? Belongs to the common IUPAC nomenclature. Okay, so benzenamine, aniline, these all are IUPAC name. Propane 1-amine, IUPAC name. Ethyl methyl amine, this is common name. So correct answer is option number A here. Okay. So now this is a homework question. Okay, which of the following compounds give a secondary amine on reduction? So just try these options and do not forget to comment down the answers. Okay, so that's what the so that was the today's class, amines introduction, where we have covered about the structure, the classification, nomenclature and the preparation of amines. So I hope you can write down all these reactions in the flow chart and then can revise it regularly. And in the next class, we are going to jump into the major part of this chapter, that is chemical reactions of amines. We'll be also talking about the basicity and all, which from where questions are generally asked. So please stay tuned for the next class, and if you like this series, then do not forget to subscribe the channel and do not forget to join our WhatsApp channel. Okay, all the very best for your KCET preparation, and do not forget your target 60 out of 60 in KCET 2025 chemistry examination. See you soon in the next class.